your preferred partner for custom software development and technology outsourcing. We offer state-of-the-art customized software development services that are client-centric, flexible, and secure to empower businesses.
All right. Good morning, everybody. Frank Antonysamy, that's the way you say it. I'm the Chief Digital Solutions Officer of Hitachi Vantara. Great to see everybody here live in person. And I'm going to start with something that Steve asked a question to the panel, right? If Steve Ballmer gave us a bunch of money, where would we invest in IoT? And he summarized saying that it was system integration. But I would also say that there's a tremendous opportunity in building solutions, IoT solutions that drive good, that drive societal good. Over the next 30 minutes, I'll talk about the capabilities, the technologies that are required, and what companies are already doing today. Right? How can we use IoT to drive societal good? And what are companies doing today? What capabilities need to come in place? What do we already have? Quick introduction. Hitachi, for those of you know, large industrial conglomerate. We make the bullet trains in Japan, the high-speed trains in Europe, power grids, industrial equipment, and so on. But we are also a software company. We have a $15 billion software business, and recently Wall Street Journal wrote an article about how Hitachi is transforming itself into a software company. And why are we doing this? Because we believe that for a lot of industrial companies, software and IoT is not an option, but for our own transformation and the capabilities that are needed in the industry to transform, this becomes extremely important. We have our roots in Silicon Valley, and Silicon Valley, we're headquartered in Santa Clara. And if you look at Silicon Valley from 30 years ago, 40 years ago, this was the seed of innovation, right? There was large problems that were being solved. This is where innovation was born. This is where the best minds in the world were getting together to solve for the most complex problems, right? It was where you had the universities, the ecosystem, the investment ecosystem, that was driving all of this big innovation. However, right, in the last few years, Silicon Valley has had an image problem, right? There seems to be, one of the early employees of Facebook quoted this to say, all the biggest brains in our generation seem to be using all of that expertise to figure out how to make you click that button that says buy, right? That seemed to be the ultimate destination of how you're using all of the power of data and AI and everything else. But we believe that there is a purpose beyond this. Right? We believe that if we're going to solve for problems using this incredibly complex technologies that we have at our disposal today, right? We've got, you heard the previous panel about the capabilities, the options that we have in terms of communication protocols, right? Are we going to do 5G? Are we going to do narrowband IoT, LPWAN? How are we going to process all of that data, right? The ability to process all of that data, the ability to learn from that data and action on each of it, right? We've got incredible capabilities, right? There are sensors and there is data sources today that we have access to, drones and from the OT environment that we did not have access into just a few years ago. So if we've got all of these capability, the processing capability, the network capability, the ability to understand and analyze this data, why not use it to solve some real problems, right? And it's not like we're lacking for serious problems today, right? If you look at climate change, right? If you look at electricity, the way it's being generated, consumed today, right? Or transportation, or even societal issues like people migration, there are several large problems that require solutions for, and we've got this incredible access to technology, right? Now, with all of these capabilities, why is IoT suited to solve these complex problems? Again, I'm going to refer you to the conversation that was there in the panel before this, where the gentleman was talking about it takes on an average 13 partners to build an IoT solution, right? What it means is that there's no single company or even a system that has all of the skills that are required to build a meaningful IoT solution at scale, right? IoT is a system of systems. And when I'll talk about some of the examples of what companies are doing, and you'll realize that for us to drive IoT at scale in the real world, to solve these complex problems, it is a system of systems. It's not an enterprise application, it's not a IT stack. It's much beyond that. And the ability to have the right digital infrastructure and the right insights to drive the experiences, the digital experiences that are required, that is what IoT brings in. And we believe that when we use all of that power for the right problems, we've got the opportunity to solve some really complex problems. I'll start with climate change. How many of you drive EVs today? Nobody, okay. All right, there's a few hands, right? Now, electric vehicles today, there's a lot of mandate in different countries about how this is going to be a big push in the future, right? Smart as they are, the electric vehicles, it's not just about the vehicle itself, but about the grid, right? A lot of these vehicles today have the ability to charge back into the grid, right? And these are, when you have to have charging, there is fast chargers, right? All the OEMs, all the auto manufacturers are pushing for faster and faster charging. And as the vehicles become more powerful, you're going to have an increasing need for high voltage charging. But you're going to be operating still on a grid that is decades old, right? So how does the grid handle the scenario where you need to know where am I going to charge at home? Am I going to charge on my way to work? Am I going to charge on a long drive? What are the demand patterns and how does the grid plan for it? How are countries solving for it? I'm going to show you a small video that talks about how the UK power network is handling this. Watch this.
By 2030, you will no longer be able to buy a new petrol or diesel car in the UK. We need to plan what the alternatives are. Optimise Prime is a really important programme that we're working on, bringing together the energy and transport sectors to plan for how our society can use electric vehicles at scale. It's the world's largest commercial fleet electric vehicle trial. It's a 3-year innovation programme and it involves a range of different companies, network operators, as well as 3 fleet operators, all running different types of fleet. Our data platform is capturing and analysing huge volumes of information and data from across all of our partners as part of this programme, and also external parties. We're looking at information around energy demand, connection profiles, location of charging points, the journeys that vehicles make, and how they need to be charged. And we're also combining that with information around things like weather, which may have an impact on all of the planning that needs to be done.
UK Power Networks own and operate the cables and wires which deliver your electricity from generators to your home, serving a population of about 20 million customers. We expect another quarter of the amount of electricity we deliver to be delivered for full electrification of transport. So the way we get ready is create the best possible forecast of what we expect to see, monitor and use data to confirm those electric vehicles are connecting, and the most important step is a smart toolbox to respond to these electric vehicles and the impact on the grid. So the challenge UK Power Networks are facing is not having full visibility of where and when electric vehicles connect. The Optimise Prime project goes a long way to help us solve these challenges.
Ultimately, we know that the depot managers who need to manage these fleets of vehicles can make sure that those vehicles can do the journeys they need to meet the customer needs that they have. Optimise Prime will come to an end in 2023. We'll collect all the learnings that we've gathered and we'll share them through the industry regulator Ofgem so that they can be collated, stored and used by anybody that wants to make their own positive changes around reducing our reliance on fossil fuels. We hope that there will be mass adoption across both the UK but also many, many other countries, and it will really help towards our journey towards sustainable energy use for the transport sector.
All right, so that, I was talking about IoT and the need for us to think about this as a system of systems. And if you look at that specific example, right, for us to build that with UK Power Networks and the partners that we needed, whether it was Centrica, the energy company, or whether it is Uber, who is transporting people and moving these vehicles, for us to understand the demand scenarios, for us to plan for each of these, right? Incredibly complex problems where different partners, different players have to be able to come together, right? which is why the ecosystem and the systems thinking, or rather the systems of system thinking, is extremely critical for us to look at IoT. Now, what other problems can we solve, right? If you look at the different studies and the US greenhouse gas emissions, the two largest contributors to this are the transportation industry and electricity, right? The generation of electricity. And how can IoT and the systems thinking that we have learned to build these things at scale, how can this be useful? Let's take climate change, for example, right? The biggest challenge for anybody generating or distributing energy is that there is a demand and supply imbalance, right? All of us saw this play out live earlier this year in Texas, where the grid just could not handle some of the generation being down, right? The ability to meet the demand and to match that with where power is being generated and where it's being supplied, it's a huge challenge. And that challenge becomes more intense as we start looking at renewable energy generation, right? Because unlike in a coal generation plant or in any other traditional generation mechanisms, in renewable energy, you're dependent on either wind or sun, right? Is the wind blowing today, right? Is it sunny? Is it shady, right? And how do you then match the generation, the demands, and the generation capability, which is where data and IoT plays a huge part, right? If you take a wind farm, if you take a typical windmill can power up to 150,000 homes a year, right? But a typical windmill is also down quite a lot, right? Because this is operating in extremely harsh environments. And for a specific electric windmills operator in Japan, when we analyzed the data, each windmill was down at least 60 days a year, right? That is because they did not have the right data coming from each of those components to be able to predict failure. When we are able to deploy IoT capabilities, learn about failure and be able to predict it, we could actually bring it down to 5 days a year, right? So bringing down the number of days where it has failed from 60 days to 5 days was able to generate, you can power up to 150 homes more throughout the year, just by that, right? So technologies like that, where we are able to, in real time, sense failure, predict where power demand is needed, is going to be extremely crucial if sustainable energy has to go more mainstream than what it is today. The second sector is on transportation, right? We said that transportation also is a huge contributor to the greenhouse gas emissions in the US. And a big contributor of that is the ridership in trains. Right? If you look at train ridership in the US, other than New York City, every other major city, the train ridership has fallen from 2012, right? This is in sharp contrast to Europe or even Latin America, where there is increased ridership because the train services are more reliable and they are safer. Right? A lot of the problems that plague North America today is because of the reliability of the train schedules, but also the safety problems. Right? This is where the Shinkansen or the bullet trains in Japan have a stellar example of how IoT and all of the technology capabilities have been able to keep the bullet trains on schedule. The bullet trains or the Shinkansen has been in operation for a little more than 50 years now. And they have a stellar track record where there has not been one fatal accident in all of these 50 years. Right? So here are these trains running at 200 miles an hour, always on time, always on schedule, and have not had one single fatal incident. Right? That is because each of these trains have more than 10,000 sensors on board. They are constantly communicating with the command control rooms, with the command center, with trackside systems, onboard systems, driving the safety and predictability of these trains. When adoption comes in, right, we spoke about 5G, we spoke about a lot of very specific network capability that is required to bring this to scale. In the US, today we are investing in specific network capability and also sensor technologies, which will give us this kind of performance. And if that drives the adoption of trains and ridership increases, then you're going to have a marked decrease in greenhouse gas emissions because a lot more people are going to be taking the trains to work every day. Right? This is an interesting problem, right? So this is an example where there's a large farmer in Australia that is using data from very different sources to make sure that in the animal value chain, right, of productivity, meat quality, and availability, how do you use data from weather, soil, the market data to make sure that you're able to drive value in the food value chain, right, and better steak? Look at what they've done. You'll also see a video followed by this about what the Rainforest Connection, right? Rainforest Connection is this nonprofit organization that's working to to reduce illegal logging in the rainforest, right? The challenge that they today have is that, by the time you can detect a chainsaw, the rangers, if they have to find out who's using a chainsaw to do illegal logging, by the time they're able to go through the dense forests and go to where and prevent it, it already is too late, right? The tree has been felled and illegal logging has happened. So how can IoT solve for this problem at scale, right? So these are the two things that we want to show you right now.
Meat and Livestock's mission is to drive productivity, profitability and sustainability for the red meat industry across Australia. And it really is ensuring that that product that consumers see on the plate is the best possible meat they can get.
We work very closely with our partners in MLA on a wide range of projects. Australian Cattle and Beef Holdings and Australian Country Choice are starting to be at the cutting edge of the beef industry in Australia. It's paramount for us to ensure that the highest standards of animal welfare are always maintained. So we like to handle our cattle very quietly. We like to reduce as much stress in the environment as we can. We've got to be very mindful that the cattle are always on a rising plane of nutrition. We're having a lot more success now of doing that consistently using data and technology. Starting to look at drones to measure not only the quality of the grass but also the quantity, and then we make livestock decisions and movements based on that.
The key to data now is all about objectivity, and MLA invests in sensors, technologies that allows us to collect more and more information objectively.
So as technology's allowed us to do it, we've then brought more and more of that data capture into other things we do. So we're now setting up weather stations where we can measure not only the rain, we're measuring the temperature, the wind. We're now starting to measure the soil temperature so we understand when the best growth is for us. It's very important that we get all that livestock data together to be able to make good decisions on where we're heading with our livestock. If you can't measure it, you can't manage it. So the data for us is pivotal to keep striving to get the best possible product and the best possible profitability.
The future's pretty exciting. The technology we're seeing today is only the start of it. We're going to see a lot bigger and better ideas coming forward in the next few years.
Rainforest Connection is best known for using the sound of the forest to help protect it. We take devices, we call them guardians, put them up in the treetops in the forests around the world. They listen to all the sounds of the forest, stream that to the cloud, and then we can pick out the sounds of threats like chainsaws, logging trucks, gunshots. Send alerts over the cell phone network to local people on the ground so they can show up and stop this activity in real time. Illegal logging is able to happen in most places because of a lack of transparency, lack of understanding, lack of insight into what's really happening. With technology, with constant monitoring, and with partnerships there on the ground, we're able to know exactly when and where logging starts. We've been doing this on 5 continents and dozens of countries over the past few years. It's truly effective, and it makes use of the 2 things that we can provide, which are great partnerships, people on the ground who would stop these things if they could, and next level technology to be able to facilitate all of that. When you think about gathering such huge data sets, continuous audio from countless places across the world, really the scale of the audio data becomes significant. The way our system works is to capture all the sounds of the forest 24 hours per day and stream that up to the cloud over the cell phone network, satellite network, any sort of network we can make use of. That's a pretty significant amount of raw data that we're streaming into the cloud, and analyzing it with machine learning for the threats that we're looking for is an ongoing, constant activity. This is a huge amount of data to deal with, and it's not, curated data. We're trying to keep the raw data so we can look for what's happening in this sound, not just with techniques that exist now, but into the future as well. All around the world in nature, life expresses itself through sound. Animals assert their dominance, they assert their territory, they express their emotions, they express their very existence through sound. Sound is movement and life. That's why sound is a really powerful tool for knowing what's out there. At the same time, sound is one of those things that people are not actually fantastic at parsing itself. There's many sounds that we can't hear, low, high frequencies, we can't hear these things. Also, it's very subtle, the way the animals express themselves. What are the questions that future scientists, future generations will wish they could answer about this moment in history? One of the most important moments in history that we've ever been through as our planet changes before us. The measure of success for us is if logging decreases over time. We want to be active in places where logging is a problem, right? That's how we can have an impact. We also want to see that logging change and go down over time. We're possibly living in the most important era of our natural history since humans have been around. This is the next 10 years, 20 years that we have to record. The way that our planet adapts, the way that nature reacts, this is happening to our planet before our very eyes and ears. We have to be able to capture it, we have to make it available, and this is a challenge that we all have to take part in.
Pretty incredible, right? I'll tell you a little bit about this project, right? So while it's fascinating for us to be able to do this, there's also classic challenges about how do you make sure that you're able to capture sounds of the forest and be able to handle all of the data, drive the workflow for the rangers to be able to identify this and go here, right? This is actually a very frugal engineering solution that the team adopted, right? They had the cell phones. The cell phones were powered, and the cell phones were actually powered by little solar panels that were attached to these cell phones, right? Because if you have to have a reliable way to capture sound in a very distributed environment like a rainforest, you need data sources that are constantly powered, and you cannot just rely on one protocol. There are some places in which they had access to tethered wired connections, but there's lots of places where it needed to be wireless. And all of us know the challenges of cell phones and running out of power, right? Most of you probably are, being tethered to the wall outlets quite a bit when you're traveling. But for us to be able to do this reliably and to power it, there was a solar panel that was attached to each of these cell phones, hundreds of them, thousands of them, and mounted on these treetops where they could collect the data. And then as you start analyzing more data, right, what you could do with it is actually increasing. When Rainforest Connection started this project, the time it took for them to analyze the data, right, the different sources of the sounds of the forest, and be able to take a deterministic decision as to, is this an aberration, is this a chainsaw, or are there other sounds that are confusing it? It took them close to 4 hours, right? But as with a lot of systems, as they started gathering more data and the machine learning algorithms helped them identify the natural sounds of the forest versus what was introduced by a chainsaw, or even the tone of some of the birds and animals, right? The detection of some of those was crucial in identifying when there was an issue that they had to go to. The other common theme that I want to talk about between this and the Australian meat farm that we spoke about is again the system of systems views, right? In a large cattle farm, you obviously are not going to be able to have Wi-Fi 6, right? The protocols is going to be there. And you need to have sensors and capabilities that are extremely robust, right? So you're going to have systems in harsh environments, be able to work on this and work reliably for you to have a continuous stream of data on which you can actually make meaningful decisions on when to harvest the cattle, right? And also, a big thing about the cattle industry, as most of us know, is that you need to make sure that the cattle is disease-free without having antibiotics, right? Even from a purely economic value, a farmer is able to sell an animal to downstream at a much higher premium if they could reliably demonstrate that the animals have not had any antibiotics, right? So it is about a lot of the technology is being used to identify and isolate animals and just by understanding animal behavior to isolate them before they can infect the larger herd, right? So as you start identifying and isolating these animals and we start identifying the feed and going into the value chain, it is economically extremely useful for these farmers to be able to use this data to drive profitability for them. So that brings us to the question, right? A lot of times there is a debate about all of this is good, but I am an enterprise and I have two main challenges. One is in the digital era, there is a shortfall of talent. Right? How do I make sure that I am able to differentiate to my workforce, and how do I retain the best digital talent out there and motivate them to work for me, right? The second, obviously, is how do I drive customer stickiness? Is all of this societal good that we're trying to good for, all of this is good, but can I drive value, can I drive revenue and profitably with my customers? And what research shows is that it is extremely possible, right? Both customers and employees value companies, and they go towards companies that are explicitly working on some of these solutions. And as you can see from this data, consumers are 4 to 6 times more likely to buy your goods and services if they see you as being a responsible company and doing the right things for the environment. So that, in Hitachi, we call this Society 5.0, right? We do not look at societal values, environmental values, and economic values as something that is competing for each other, especially in complex technologies where we have to invest across the board on system of system solutions. We believe that the societal value, environmental value, and economic value that can be provided by large enterprises actually complement each other, right? Whether you look at the windmill using the technologies that are required to make sure that you're driving renewable energy, but you're helping the company that runs the windmills to be more profitable because you're reducing downtime, right? You're reducing downtime of each of these windmills, and therefore you lesser operational cost, higher profits. Talk about the train operating companies, right? As the ridership increases because the experiences are higher, you're contributing to reduction in greenhouse effects, but your ridership also increases, right? Increased profitability and revenues that are driven from them. So every single example that you see here, there is an opportunity for us to deploy each of these technologies that complement the societal value, environmental value, and economic value. Which brings us to the topic of this, where saying it is possible for us to drive societal good through IoT without compromising on the financial success of a company, right? So that brings us to the end of this. We're going to be around. Thank you for listening in. I do hope that you have a good rest of the conference and enjoy your time here. Thank you.